Section 1.3 is about the midpoint and distance formulas. On the practice worksheet, you'll be doing numbers 1 through 13 odd and 15 through 24 all. I'm going to look through the worksheet with you, and then I'm going to just do a couple on a separate sheet of paper to help you out. Right now we're getting familiar with the notation. If the length of AC, find the length of AC if the length of AB is 6 centimeters. And we talked about this in the last section. These little marks mean that AB is congruent to BC, which would also mean that line L is bisecting this segment. So if AB is 6, obviously, what does AC have to be? So I'm confident you guys can handle those. Number 7, line CD bisects AB at point, segment AB at point C. So you have a segment, a line bisects it. They tell you what AB is. Draw your picture and label it. Incidentally, you can bisect a segment, but you cannot bisect a line. A line goes on forever, so there's no way to bisect it. A line can bisect a segment, but not vice versa. In each diagram, M is the midpoint. A line can bisect a segment at its midpoint. A point is a midpoint, halfway between the two. So again, if M is the midpoint, XM has to be equal to MY. That's the definition of midpoint. And you can write a relationship. Solve for X, but remember to find the quantity they're asking for, the length of XM, the length of MH, etc. Here's where things get a little more complicated. Find the coordinates of the midpoint. I'll do a few of these in a moment. Now they're giving you one endpoint and a midpoint. They want you to find the other endpoint, the coordinates of the other endpoint. And here they've plotted 2 points on a coordinate plane, not horizontal or vertical. Find the length of the segment. That's the distance formula. We'll talk about that in a minute. Find the length of the segment. Then find the coordinates of the midpoint. I think these are easy enough to do just to look at them. The endpoints of 2 segments are given. Find each length. Tell whether the segments are congruent. So now, rather than actually drawing these on a coordinate plane for you, they're just giving you some coordinates, and it's good practice to plot those. So that's thunder. This is 1 through 13 odd, 15 through 24 all, because I'd like you to practice quite a bit of those. So let's talk about midpoints, length, etc. That startled me. Okay. So suppose I give you a segment RS, and I tell you one endpoint is 1, -3, and the other endpoint is 4, 2. I think the best thing to do is actually look at this. Let's get a feel for what it looks like. You don't need to, and it's always good to label your points. Doesn't matter which one is 1 and which one is 2. A lot like slope, and that will come into play. So let's make sure I plot these correctly this time. You should have some form of scale. 1, 1, 2, 3. 1, -3. There's R, and 4. 1, 2, 3, 4, comma 2. There's S. So here's what we're looking for. Now the midpoint formula says this. Well, I need to be halfway between the x's. So it's x1 plus x2 divided by 2. And I need to be halfway between the y's. And so it's y1 plus y2 divided by 2. That's how you find halfway. So since my x values are 1 plus 4 divided by 2, my y values are -3 plus 2 divided by 2. And this gives me 5/2. or 2.5, and this gives me -1/2. So I'd be at 2.5 and at -1.5, and that looks about right. We'll call M the midpoint. So that's how you would find the midpoint. Suppose I wanted to find the length of this segment. Well, the distance formula looks like this. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, why is that? That's because, and I'm going to put the 2 points down here again because I lost them when I slid the page up. x1, y1, x2, y2. But look at this. It's the Pythagorean theorem. How big is that? 3. And how would you get that? You would do x2, which is 4, minus x1, which is 1. There's your 3 squared. And then what's the difference here? 1, 2, 3, 4, 5. That's 5. So how would you get that 5? That would be 2 minus -3, y2 minus y1 squared. And because you're squaring it, it doesn't matter which order you did. If you did -3 minus 2, you get the same thing. So I'm going to have 3 squared plus 5 squared, and in the end, a squared plus b squared equals c squared. So in the end, I have to square root it. So d is the square root of 9 plus 25. So d is the square root of 34. Can't simplify that. I can take the square root of that. If they ask me to do it to the nearest tenth, I get 5.8. So I have a little pet peeve about the distance formula. It's just the Pythagorean theorem, which most of us know. But it's nice to get used to using coordinates and plugging them into templates to find distance and midpoints. Something that is a little more complicated is, suppose I give you an endpoint and a midpoint and want you to find the other endpoint. So suppose I have a segment VW and I tell you V is 4, 4, and I tell you that the midpoint M is -1, 2. I want to know what W is. Well, you could use the formula. If I call this x1, y1, and this is x2, y2, that's what I'm looking for, I know that my midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So I'm going to separate them. I know that x1, 4, plus x2, what I don't know, divided by 2, will be the x coordinate of my midpoint. And then y1, which is 4 as well, plus y2, which I don't know, divided by 2, will be the y coordinate of my midpoint. Multiply both sides by 2. 4 plus x2 equals -2. Subtract 4. x2 should be -6. Multiply both sides by 2. Subtract 4. y2 should be 0. So this should be -6, 0. Now, another way to look at that is if I went from 4 to -1 and I only went halfway, how far did I have to go? I had to drop 5. So if I drop another 5, obviously I'm going to be at -6. -1, drop 5 more will be -6. That makes sense. If I went from 4 to 2, I dropped 2, but again I only went halfway. So my second half I dropped 2 again, so 2 minus 2 would be 0. So that kind of checks out. 2 different ways to do those. I think that covers it, as long as you know how to find midpoints the distance formula or just the Pythagorean theorem. If you're working on a standardized test, I feel like 3 squared plus 5 squared would be quicker rather than trying to plug all this in, label your points. Again, it's a skill that's worth working on when things get more complicated. However, you guys know the Pythagorean theorem. And this is a little, given an end point and a midpoint, how do I find the other end point? You could do it formulaically, or you could think about this and conceptually. And if you label things in that order, 4, 4, -1, 2, -6, 0, and think about what's going on. It doesn't even matter that these aren't in a straight line, that they're somewhere on the coordinate plane. I mean, they are in some kind of straight line. It doesn't matter that they're not vertical or horizontal. You can pretend it's horizontal, so to speak.